Let's start.
Okay, Indranil sir is also on leave or is joining?
He's in, but don't know if he is in some other meeting.
Okay, okay. All right, let's start then. So this is the welcome everyone. This is the follow-up meeting of what we discussed around 15 days ago about microservices. So we already discussed 12-factor app and many things about microservices. We were here in between of inter-process communication, right? We discussed the evolution journey of software, monolith architecture, so architecture, and then microservices architecture. We have already discussed all the 12 factors in brief and the pillars of microservices as well. And then we move to designing the architecture part. And we were focusing on these three main points. The mapping we discussed in length, how to split uh, into bounded context, and then we discussed the technology stack part as well, and we were discussing the designing the microservices architecture here. We were here. So let's move to the components we have discussed. These two we have discussed the e-commerce example, and then we were in the communication pattern part. We have also discussed three ways of communication: sync, async, and pub sub. And in synchronous one, we were talking about the direct connection between the services. We were discussing this forms a spider web kind of a structure when multiple services talk to each other directly, right? And we discussed that if the red ones goes down, what will happen? This will cause a ripple effect in a distributed system, and it will be too difficult to maintain, the talk between among services. So let's draw the image of this, and then we'll discuss what all solutions we proposed in last meeting, and we'll try to visualize it. I was actually drawing this online. I was using a software called app.diagrams.net, and I was trying to uh, draw that spiderweb kind of structure in microservices format. All right, so this is similar to direct connection that I was trying to draw here. Hope you can see. Do you guys see my Chrome?
Yes.
All right. So here, what we see here, this is the client. You can see this is this. You can see this is confirm or web, or this is Android, or this is third party, and every client is talking to microservices. This can talk to this as well, and this as well, and this as well if need be. And again, this is the box where it has its this microservice has its own database. All are having its own databases. There could be some aggregate microservices as well that can talk to this and this and this also, and then aggregate the results, and then client can talk to that microservices. Now here we can see client is directly talking to the microservices. Now what is the problem here? Because in distributed environment, in microservices architecture, many instances are being created, and many instances are going down and shutting down as well based on the load balances. So in this case, in direct connection, the client as well as microservices, if it needs to talk to another microservices, it has to maintain the IP addresses and port number as well, because there are a lot of moving parts and it's dynamic in nature. So what we proposed here is, instead of client directly or even one microservices directly talking to another microservices, instead of direct connections, we brought the gateway into the picture. Now uh, let me delete this, or you can uh, let me resize it. All right. So and this also, there will be no direct communication between the microservices and the clients. So let me bring something into the picture. कौन सा डब्बा यहाँ फिर आएगा?
ऊपर वाला रेक्टेंगल, हाँ.
Right. So So now what I have done is, uh, I have brought, say, API gateway into the picture. Sorry, text. So now this is the gateway. This has come into the picture. Now, if client has to talk to any microservices, client has not to worry about the IP addresses, the moving part or port. What it will do is it will directly talk to this. This will also, this will also talk to this, and this will also talk to API gateway only. And now API gateway will talk to microservices and bring the returns, bring the results back to the client, right? And again, not only this, even microservices, this microservice has to talk to this. This too will talk to API gateway and fetch the, a complete address, and then the call will go to microservices. And now how that IP addresses and port will be maintained. We said there will be a service discovery pattern in between, and that will maintain a service registry. Now again, there will be another box. Oops. Let's bring one more box here. This is your service registry. Now, what it does is it has its own database. It's kind of yellow pages like a structure where multiple instances are getting created and multiple are shutting down. So it will listen to the events that is responsible when a new instance is getting created or shutting down, and according to that, it will maintain this service as this IP address and port number. And from this registry, the gateway will talk and oops, this is not, I'm not handling this tool. Okay, so kind of it's the API responsibility to fetch the current address, updated address from service registry, and then it will serve it will it will reply to the client response, whatever request it has made. Now it will am I making sense here?
And so we'll have two-way communication between microservices and gateway.
Yes, earlier too it was happening two way. Earlier client was directly talking to microservices. Now
Right.
in that case, client had to maintain the URL address, IP address, as well as port number, and even microservices had to maintain the same, right? Now instead of that, API is maintaining that, and so, and with the help of registry, right? Now microservices are worried about their business logic only. All the communication part is now being handled by gateway with the help of service registry, right?
Right.
Okay.
Uh,
Hello. Yes.
well, I have one question here. So suppose everything is dependent on the API gateway here, right? So what
Mhm.
if my API gateway goes down because that is acting like a single point of failure? If this
Right.
goes,
Yes, there is something called BFF. If you know that, that is back into front end. Let me bring that picture as well. Uh, it's similar to API gateway. What we call it is BFF. Now, what it argues is instead of one API gateway, you can have two or three or even more multiple gateways based on your nature of work.
okay, so something like active passive.
Right.
Okay, yeah, that makes sense.
Okay, so this is also an architecture and similar to gateway. So this we also keep a note of. All right, so we talked about what else? Let me go to PowerPoint slide. We
Okay, so
brought
sorry,
picture.
one more question. So when you say microservices and everything is like communicating with the different databases, so
Mhm.
databases are also microservice or these are hosted separately? So I mean, these are loosely coupled microservice or like tightly coupled?
So you are saying microservices and the database, they are tightly coupled or loosely coupled, right?
Yes, yes.
No, that is tightly coupled because see, that too depends on the nature of work or the how complex the situation is. For example, you can use NoSQL or even you can do database sharding as well. I'll talk a little bit about database sharding as well in the coming slides. Suppose in case of DynamoDB or Cassandra, it saves your information into different nodes, right? And if one node goes down, another will solve the purpose. There are again master slave architecture in distributed database system as well. So even if it is tightly coupled, it has fault tolerance and it will solve the purpose in case one node goes down.
Mhm.
Hello,
Okay.
was that your question, or are you trying to ask
Yeah, I mean
something
that
else?
makes sense. If you have a NoSQL kind of thing, that so basically we can use a sharding and
Yes,
that
yes.
better high
So that
availability.
too depends on the problem statement. If the service is not too big and there is not too load, there could be RDMS database as well that will also solve the purpose.
Yeah, that's
So
right. Because
case to case it has to be decided.
yeah, why I'm asking is like because in the microservice world,
Mhm.
the when you make the database as the microservice, that's something like not recommended. So it is always like separate because your containers are dynamic in nature, and if
That is on different container.
okay,
But again, that is not also it's not thick line that it has to be on in the next box. This can be inside your microservices as well. This can sit here as well, or even some of the microservices may not have their own databases.
okay,
That again depends on the solution you are proposing, and that depends case to case basis. It varies.
okay, yeah, that's what like when you are doing a tightly coupled
Hmm.
microservice, wherein your database is also there and application is also there in the same pod. So when I say
Right,
pod, two containers, for example, when you're saying tightly coupled. If your
right,
pod dies, your database is also gone.
right. In that case, yes, definitely. So again, if you think there are too much load on that microservice, definitely more than one instances of that pod would be running. So
Right.
fault tolerant will be there, but yes, if it is a it is a single instance, and definitely, and in that case, there should not be any tight coupling between microservices and the database.
Yep.
It
Yep.
has to be on two different
Separate.
pods in that.
Right.
Yes.
Right.
So again, case to case, there is nothing, no bold line that this is the only way. That is not
Yeah. Yeah. That depends on the scenario. You're right.
right.
Okay, so I have a question like how we can
Yes.
authenticate clients to access the microservice.
Come again. What were
Yeah,
you saying?
like is there any way to authenticate clients to use
Yes,
microservice?
yes, yes, yes. We talked, last time as well. Your API does API gateway does the authentication part, the SSL termination even, or even the load balancing part is done by the API gateway, and the installation also. These many things are covered by API gateway itself. There will be if you can even create a microservice that does the authentication part. Means for every request, every single request, it goes to that microservice to authenticate it, and if it is validated only, then the call will go to another microservice to bring the results.
Yeah. So basically, you have to expose the communication between those. and exposing the service basically.
Right.
Okay.
And that part is being handled by gateway itself. This can be configured that way.
Yes, because anyway, the microservice is not supposed to be accessed by clients directly. So client has to first go to the API gateway. And I don't know if you're aware or not, Mohit, but the IoT work we are doing, all the services that you can call that just service, not the microservice, but those services are exposed via API gateway using AWS API gateway. So even if, when we are trying to create a new inquiry using the IoT data, that is not directly calling the custom confirms web API. It is calling the gateway, and gateway internally calling the confirm web API, which creates the new inquiry in our confirm database. And at the API level, I don't know now what is the situation, but earlier we used to have the API key, I guess. That API key, I mean, the caller has to supply the API key, and then only the API gateway will consider that caller as a authenticated caller and allow him to proceed further. So these kind of things are managed at the API gateway, and that is the benefit of having the API gateway in between.
Okay.
I'm not sure now what is the situation. Because I remember they were thinking about putting some credential also for the API gateway, that okay, that credential will be used rather than just the API key. Don't know if that has already been implemented.
Yeah, I read somewhere like we can use Cognito as well for
Correct.
authenticating.
Yes, that also can be used. Yes, that's true.
All right. Let's move ahead. Yes, we talked about service breaker as well. So with this pattern, what it does is we already discussed. Suppose this can be configured if a microservice goes down or overloaded. The circuit breaker will, return 404 with cache data. If you have configured your service breaker to return cache data in case of service goes down, or even you can even, you know, um, you can have a fallback mechanism as well. Suppose a third, you can redirect the request to the any third party that does the same stuff, and it also does the healing the affected service as well. It gives some time. If it is overloaded, it will in due course of time it will respond correctly. And so after some time, this part is done by the service breaker. So where it stands is this stands in between here. So let me put a service breaker box as well for every microservice. It will There will be a circuit breaker if need be. Again, this is not a requirement, but yes, if your problem statement says so, then you can configure it. In case of this goes down, say, what happens is, this is like similar structure that we follow in our organization. What it does, suppose your reception is a microservice in an organization called Pitney now, and the reception is on leave today. If you make a call to the reception desk, no one will respond, and you'll get not connected after 50 seconds of ring. Now another person calls the reception, and then again after 50 seconds it will got disconnected, no, not answered. Now what in case of service breaker implementation, immediately you'll come to, after two requests, again you may retry also, again you'll call again thinking that reception is back. But if reception is on leave that day, so what circuit breaker will do, it will, the moment you call, it will give you 404 that reception is on leave today. It means your time will be saved and there will be no need to retry, right? Or suppose your bay is freezing. Now what you used to do, you used to call reception and to raise the temperature of AC. Now in that case, circuit breaker will automatically redirect your call to some security staff, and he or she will also do the job of raising the your base temperature. So service breaker here is doing the same stuff. It will give you the cached response, or if there is a fallback mechanism, it will redirect your request to there, right? So again, need to need case to case basis, you can bring service breaking pattern into the picture in microservices ecosystem.
Mhm. Does it know when the service is up, like when reception is back? Will it know that yes, it is back now?
Yes, you can
Okay.
configure it. Okay, try it. uh, do the health check
Every
after
8
every
hours.
five
Every
five
eight
five
hours.
minute or 1 hour.
Okay.
And in
Okay.
that case, if it gets starts getting response, and then you will say, okay, it's up and running now, and now it will it will honor the request.
Okay, so instead of every time calling the microservices, this service circuit breaker itself will manage that and give you the response back, either the return 404, or it will give you the fallback if you have any other
Right.
service
Even
instead of
it will give you the cached data as well, if
data as
you
well.
can configure it that way
Right.
also.
Okay. Okay.
So let
Okay.
me name it circuit breaker. Okay, so these all boxes are circuit breaker. Now what did we talk yes, service mesh. We talked about service mesh as well. It's another kind of pattern. We already have talked about it. So everyone has Fiddler installed in their system. What does it do? When you open Fiddler, it records all your outgoing or inbound calls, right? And after 1 hour of work or 2 hour of work or 1 day of work, if looking at Fiddler, what outgoing or inbound calls I have make, you can create a map, you can create a matrix where the load goes, actually which server do you access very frequently, which you don't, right? Service mesh does that stuff. What if a service is broken down or is overloaded, and a service needs to talk to that service? Does it needs to retry? What is the timeout? Does this service need to worry about? Do you need to configure service mesh for that? It actually does load balancing as well, and maintains service discovery, maintains matrices of number of retries, circuit breaking, timeouts, etc., etc. Right? You can configure your service mesh, you know, uh, what timeout should be, how many number of retries you should make for a particular service. These all can be configured using service mesh, right? So this is actually, I we discussed that it's of two kinds: sidecar or in process. It can either sit inside the microservice box or side by side. So if I go to the picture again and I try to draw the service mesh, it should be something like, let me put this box kind of this. If it is inside the microservice, service mesh, right? Or even it can sit outside as well, as I given you the example, um, like mesh or istio. You can have this configured outside your microservice box, outside this bounded box. So I've just drawn one only, and for all the other also, if you need to configure, if the problem statement says so, you can do that. Next, yes, we
Well,
discussed. Yes.
so what this service mesh will do once it actually identifies the different network flows in microservice.
Right.
Let's say
Say
it identifies, okay, this is the endpoint which is hit most of the time. This one is the one which is hit mostly 10% of time. So what exactly it will draw from that data, and where that data will be used?
it will help you maintain the load balance. Suppose many calls are coming to this microservice, definitely a new instance need to be created.
So where that data will be shared, which component in
with
this
with
diagram
API
will
gateway.
use?
That matrix will be shared with API gateway.
Okay, so this mesh itself will be capable to send that data to gateway, and
Uh,
then gateway need to store it somewhere,
again, again, uh,
or
again, that depends on configuration as well. It could be two-way as well. Either API gateway does the fetches the health information from the service mesh of one particular service, or even it can trigger event that your gateway is subscribed to. Are you getting me?
Okay,
It can publish
but all
many
the
events.
all the
Yes,
calls are already going through the gateway itself. So why not put this mess in the gateway itself?
because one mess has to worry about, it's limited to one microservice, because it is worried
Okay.
about a particular microservice, not at the gateway level, because Fiddler needs to be installed at particular system, right? You cannot install Fiddler on server and see you are hitting this, he is hitting this, and some third person is hitting this.
But in Fiddler,
Mhm.
okay,
With
in
Fiddler,
Fiddler, okay,
I can see you have hit that server, that is down. You have hit that four times and still that is down. Yes, if we come again. Hello.
okay, that's fine.
Mhm. Should we move ahead? Okay. Okay. Now we are talking about async implementation. We talked about, there is always a direct even though we have brought gateway, circuit breaker, service mesh, and service registry into the picture. Still, if this client has to talk to this microservice and then this microservice, again there is direct call going on, right? Suppose for any reason this microservice is slow and responding late. In that case, uh, it has, and this has to talk to this microservices as well, then definitely there will be a delay in response, because uh, first this will return the results, and then on the basis of that it will go to this microservice, and then so on, right? So this, again, the direct communication between microservices is not recommended. So how can we make the asynchronous call between all the microservices? So we have to bring queue into the picture. As you can see here, we have brought the many queues as well. Mostly the widely used tool is RabbitMQ here. So what we will do is we'll bring queue also into the picture. So let me create the queue somewhere here. So this is your queue. Now instead of this arrow going here, this will go to this queue first. It means, and this service will listen to this queue. Now what happens is, now suppose I have to, in e-commerce example, um, you're purchasing something and you are making payment, right? Now what will happen behind the scene? The thing that you have purchased will be deducted from the inventory first, right? And then it will go to the order services, and then it will go to the payment service where you'll make the payment. Now what we all do shopping from online e-commerce sites, and often we see that even after payment there is a delay in response. The order is not yet confirmed, or even after confirmation I get the cancelled order, or even I may cancel it manually, right? This all happens because of you know there is no direct communication between microservices. Had this been direct, or you'll feel the delay between the responses, right? That is why there is queue into the picture. What it does is, when you make the payment and the payment is successful, it sends the notification into the queue, and your inventory listens to that queue, your orders listen to that queue, and then suppose at that particular moment the inventory microservice is not running, right? In that case, what will happen? Your payment has been deducted, but meanwhile, say behind the scene the inventory has run, it's running out. The thing that you have purchased, suppose you have purchased a laptop, and there was only one piece of that laptop in inventory, and that is also sold out. Now you have made the payment, someone also have done the payment, and inventory is out now. So once the payment has been done and the inventory service is now up and running, then then from the queue it will come to know that okay, another purchase has been made and laptop is no more in the inventory. So you'll get the order cancelled message uh, after a delay of 5 minutes or 10 minutes or whenever the service is now up and running, right? So these kind of issues will happen to when we bring queue into the picture or we bring asynchronous communication into the picture, but this is the recommended one because you get in that case you are not waiting for response from a particular microservice, right? We are not talking about consistency here, we are talking about eventual consistency in microservice ecosystem world, right? It means ki whenever all services start are up and running, they will come into consistency, but not right now, not at the moment, but yes, eventually they will be consistent with each other. And if need be, the customer or client side gets notification in case it is not, and it will notify you that okay, your order has been cancelled because of this reason, and it will bring all the databases, all the microservices in sync, right?
So
Uh,
Ved, now as you have introduced the
yes.
queue
Queue,
here, so this circuit
right?
breaker should talk to the microservices via queue, not directly to the microservice, right?
True. It
Then
means
that arrow, yeah,
ki API gateway
will
will
talk
send the
to circuit
yes
breaker.
queue.
Yeah,
Yes, yes, yes.
circuit breaker. So your arrow on the first box, your arrow should now come back to the circuit breaker.
Right, right.
That's
And
so
then the
great.
queue. Even yes, yes. Even I was talking about fault tolerance.
Hmm.
Was there any other question, Hariram?
No, I think Lakois was asking something.
Yes, Lucas.
Yeah, so I was just asking. So we have like online transaction processing, like OLAP and OLTP. So
Mm-hmm,
can this be made into the picture in this scenario, basically for the e-commerce side? So whenever you are saying that only one inventory is left here, but
mm-hmm.
you guys are like trying to purchase one inventory and one
Right,
will be to buy, right? And there is
right.
a difference of like milliseconds. So can queuing handle that, or like OLTP, OLAP can replace this queuing? Like when I say queuing, it can be Kafka or SQS.
Right, right. True.
So can OLTP be replaced with queuing in this scenario, or like how feasible it will be?
Oh, I do not understand OLTP. Can you explain what is OLTP?
Okay, so basically online transaction processing, it's like a kind of mechanism which
Mm-hmm.
really fits into this scenario. Like suppose mm, one laptop is present only in stock, right? And you and me
Right.
are trying to purchase that same laptop. You have
Mm-hmm.
done the transaction on 1 p.m. and I'm doing the transaction on 1 p.m. 1 second. But
Mm-hmm.
inventory will be allocated to you and not me, because that milliseconds and the gap of that 1 second will be handled by this online transaction processing. I don't know how it takes place at the backend, but it can be used as a microservice also.
Mm-hmm. No, this could be a problem. This could never be a problem in a monolith architecture because you are using, suppose you are using a relational database, definitely there will be a lock at the time of purchasing, and definitely no one can place order at the same time, right? But there is
Right.
a cost associated with it because there is a direct communication between your service and the database, and there is a lock on the table. It means no other customer will be served at that time for that inventory, right? But with asynchronous and bringing queue into the picture, you have given the liberty to the customer. Okay, many simultaneous purchases have been made on that inventory, but yes, this has come at a cost of eventual consistency.
Hmm.
Order may be cancelled. That depends.
Okay. And we can have some exceptions for, because when you're using queue, there can be some dead letter queue also. So DLQ can also happen, which can result in like some errors. Because if there is a dead letter queue, it will not be processed.
Deadlock, you are saying?
No, no, dead letter, DLQ, which is like happening in the SQS or Kafka or any kind of like queuing mechanism,
Okay.
which does not send you any response. So that's the dead letter queue. That does not give the response to the microservice basically.
Is it
Okay,
Lucas
that
failed queue or something like that? items
Yes.
which are failed which will be pushed to that failed queue.
That's again, very rare scenario, because when we talk about Rabbit MQ, I've already created a Microsoft application using Rabbit. That's fault tolerant in itself. High availability kind of stuff. That's very rare scenario that your Rabbit MQ, is broken or has
Yeah.
gone down.
That only happens in the scenario when you have millions of transactions per minute or per second. In that case, you get some dead letter queue, which gets processed automatically after wait time, like suppose 4 hours or 4 day, it can be anything.
Mhm. Okay.
Yeah, so that depends on the queuing mechanism which you are using and what is the timeout on the dead letter queue.
Right.
I think from microservice point of view, the what microservice suggests that you should use a queue to implement a microservice.
Asynchronous,
But
yes,
yeah,
asynchronous
yes,
communication.
but yes, low case is also right that there could be mechanism which can give more efficient use of queue. That is something which is, I mean, which is generic thing, which can apply to any e-commerce organization, right? But as for
Right.
microservices point of view, you should have a queue so that you can make asynchronous calls in your architecture, right?
Right. Okay, let's move ahead. Yes, we talked about pub sub kind of communication as well. We already do it in monolith as well. So again, kind of fire and forget when just like click of a button. We talked a bit about today as well. So you can fire any event, and those who are subscribed to that, even in case of uh, payment case, if I made a payment for a particular item, it will raise an event that your inventory is subscribed to. Even you I have made the payment, now inventory will listen to that event and will deduct that one that deduct the laptop by one quantity, right? Again, the order will also subscribe to that, so that it will show you the order has been placed successfully. So it's kind of all, you implement asynchronous as well as pub sub event driven way of communication as well in your microservices that we already do in monolith as well. So again, this we already have we discussed. Yes. Okay. We talked about bounded context. There's a question related to it. Do you guys see this? Hello.
Yes.
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 So, will anyone answer? It's basically it's a logical domain. The second one, we have already discussed it, that prevent a microservice component from overstepping its bounds. A department is completely, kind of isolated from another one if need be, but not for every call it talks to another. But yes, on need to need basis, it will talk to other bounded context, but not for every requests. All right. So,
So just one thing on bounded context. Is every
right.
bounded context a microservice?
Not necessarily, but yes, it's kind of, logical bounding
Mm-hmm.
that, that isolates your database as well as your, kind of offering as well as a service from
Mm-hmm.
another context. Contextually, it should be isolated from another. We talked about, departments, HR department and finance departments. They are different bounded contexts. Logically, they are separated.
Yeah. But not necessarily what you're saying.
but not necessarily, right?
Okay.
Okay, so we are familiar with this. There are many development platforms that we use in microservices or in even our monolith architecture. But yes, two microservices can use two different technologies. One could be in .NET Core, another could be in Node.js or Java or PHP, and they can talk to each other. So platform, is not the restriction in case of microservices, which is definitely in case of monolith. Right? Everything is in .NET. But if we suppose in our case, if we separate our mapping microservices from conform world, then this can be developed in any other language. Say we develop it in Node.js, that is pretty much possible, and we can do that, right? So this box gives you, what all technology you can use, what is the size of their community, is that support cross platform or not. So you can see .NET Core, it's its community is growing rapidly. Similar, like mostly we used technologies are Node.js and .NET Core in microservices world. Let's move to data store. So in every software industry, we are using four type of data store: relational or even SQL or NoSQL, and cache and data store. We will talk more about cache, but let's in case of relational databases, we already use Oracle and SQL Server. We are familiar with relational databases, even MySQL or PostgreSQL. These two are relational databases, and there are many others as well in relational databases. In when we talk about NoSQL databases, which is schemaless, and usually we store the data in JSON format. Uh, NoSQL databases are like many. There are many popular NoSQL databases like Amazon DynamoDB or Azure Cosmos DB, Couchbase, MongoDB. These are popular NoSQL databases. Uh, there is a concept of database sharding as well. I think we discussed it last day, but what it does, it does the horizontal partitioning of your databases to spread the load on the database. So what in case of database sharding, each shard is held on a separate database server instance, and each shard or each node acts as a single source of the subset of data. In this case of database sharding, these databases support in case of SQL, like Cassandra or HDFS, MongoDB, Redis, MySQL, PostgreSQL, and these databases support database sharding. In database sharding, what you can do is, suppose for example, suppose there is a table called user. Now I can configure my database, suppose Cassandra, to store, say, username starting from A to Z, to store this user's information in node 36, and from K to P, um, usernames will be stored at different nodes, say 79. So if the 79 say fails, the node 79 fails, you can still have master slave kind of architecture, and if the master fails, slave will come up and serve the purpose. It will serve your request, right? So in microservices world, database sharding is pretty much popular, and normally for heavy loading we use Cassandra or HDFS or MongoDB kind of structure, or Postgres, that supports database sharding, and you can serve the requests, saving the data at different nodes and make it fault tolerant. The third one is kind of cache, where we store the in-memory data for faster access. Again, if we talk about cache, the most popular cache tool we use is Redis. So if we again go to same drawing and bring Cassandra or any other um, cache into the picture. So let me draw a cache here. Now what it does is, instead of this microservice hitting this database, This can fetch the information from cache and return the result immediately,
But
right?
again, it depends on what kind of data you are pulling or storing in
Exactly.
cache, right?
Exactly, right. It depends on, nature of work. Suppose it's a blog kind of stuff. Suppose in Twitter something is trending,
Yeah.
right? It is being accessed very, very frequently. Then you'd be, you can put that particular tweet into the cache instead of database. So this is, we can call it a Redis or cache. This we do in our monolith as well. So what happens in cache, you can bring node in picture as well. As like database sharding, you can shard the cache as well. You can save the cache at different nodes. There is a concept of quorum here. What it does, and there are two concepts. Suppose you have stored something in cache, and that record is definitely residing in database as well, and database is the single source of truth. And what happens if database gets updated and your cache does not? In that case, you are serving outdated data to the client, right? In that case, there are two patterns come into the picture, that is write through. It means if client is updating something, that will update. So your service will update that information into cache as well as in database. So before saving that information into the database, it will save that information or update that information into the cache, say your Redis, and then into the database. That is called write through, or even write back mechanism pattern. That two you can follow. First save it into the database and then save it, update it into the cache, so that all users are getting updated information. There could be some delay into between the two, but that two depends on case to case basis how important your data is. Suppose that is financial transaction, that definitely will not put into the cache. Definitely data in that case, database will be only the source of truth, and there will be no cache into the picture to serve the financial transaction kind of stuff, right? And third option that we talked about is object store. We already do this. Instead of putting your data into the database or in cache or in NoSQL or SQL database, you may save some documents or photos or files that we do usually you know um, in another file system. Say we are saving all the photos or videos attached to a particular entity, say job or defect. We are storing that object into S3 or Microsoft Azure blob storage, or you can there are many popular storage available or at different cloud storage in cloud storage environment. There is something called Minio as well. If you're not using any cloud application, cloud storage, you can use Minio as well, that actually simulates the cloud storage. So basically there we discussed four types of data store, and these are the stores that we use in microservices as well as any software world, but they're pretty critical in microservices ecosystem, right? Now let's briefly talk about logging and monitoring. It's already 124. Okay. So we know we already doing logging in our monolith application, and that is more critical in case of microservices, because there are a lot of moving parts. Um, a lot can go wrong in case of microservices world, because we see here there could be wronggoings between the here as well, between the network and the microservices. Even one microservices is down, another is not, even service registry is not. A lot of things can go wrong. So logging and monitoring both are important. Logging means you know you can use either Stack or Splunk. We already, I think, some clients are using a Splunk to read the log or to manage the log, and it gives you clear picture what went actually wrong, right? And in case of monitoring, basically you need to monitor your infrastructure along with applications. right? I'm not going through all of this because time is running out, but yes, we already uh, do this part in task process. If you go to the task processor architecture that we have created, there are a lot of monitors thread in task processor that monitors, because in task processor we have seen that there are a lot many moving parts there as well, and we have seen many things can go wrong in task processor. So we are monitoring. There is a monitor thread as well that monitors all other threads. So similar kind of architecture is being developed in case of microservices ecosystem. Let's move. Yes, and for monitoring as well, there are different many tools available in the market. So for every problem statement we have seen in microservices, there is a tool available, which was not in case of service-oriented architecture in 90s. And that is why microservices is, kind of getting momentum. So we talked more about microservices. There are many scenarios where microservices is not the answer. It doesn't fit for every problem statement. So for example, if your system is pretty small, it's too simple and not complicated, in that case definitely you should go for monolith only and not microservices. Ag- Again, if you think you can break your monolith application into just 2 or 3 services, then better not to go through microservices way and stick to monolith, because bringing 2 3 microservices only into the picture, again you'll make the system complex, more complex than monolith, and will again solve the it is not going to solve the problem at hand. The second type of, if there is too much intermingled data between the services, you cannot, logically create bounded context of a monolith application, then better not to use microservices. If two departments are, pretty much, coupled and cannot be decoupled in any way, then definitely microservices should not be the choice. Also, we have seen there are a lot of network coming into the picture, so there will be slight delay in responses. So if your application, your problem statement is performance sensitive, too much sensitive to performance, then better not to use microservices as well. And again, if you are creating an application in pretty quick and dirty kind of stuff or POC kind of stuff, then also microservices is not recommended. Again, you should evaluate it on case to case basis whether you should go for microservices or not. But if you are not working on a project or not product, and you have no planned updates, then better not to use microservices and go for microservices. There is a concept of
Perfect.
micro.
One small question here. So when you talk about like, if I'm talking about the conform architecture, basically in context of conform,
Right.
if we are thinking of making the conform configuration service, that's the CCS component as
Mhm,
arise. So how
mhm.
feasible it is for our architect?
Actually, have you seen the strategic asset management part of Confirm, SAM?
Mhm. Yeah.
Okay, so if you go to the database and let me show you SAM underscore, you can see 10 or 12 tables that is prefixed with SAM underscore, right? That tables are used in strategic asset management web application only and nowhere else inside the Confirm. Okay, and that does not mean SAM does not interact with rest of the tables of Confirm. It interacts, but not every now and then. It interacts for certain amount of time, and when it has to fetch some data from Confirm and then do manipulation over that. So in this case, I would say SAM is a best candidate of microservices, strategic asset management, because it is isolated. It has its bounded context. It is going to be used by a different level of management only. So it is completely isolated. I have not given a thought about CCS, but if you want to break that, you have to give it a thought. It should not be decided 5 minutes or 10 minutes discussion. Proper thought, you
Mm.
have to um, see if it is actually feasible or not. I have
Right.
already taken a screenshot of what John has shared. Yes, this was the path to microservices where four products are coming together, and we were talking about creating mapping as a microservice, scheduling as a microservice, valuations as a microservice. And at the end, we are proposing actually 35 to 40 microservices when all the four products are, you know, joined with each other and serve the exactly one purpose. And then accordingly, when the new acquisitions will happen, that too will, you know, will be broken down into different microservices, the best of all four systems.
Right.
S-
Yeah. So
but
maybe
yes,
I'll be able to
I
catch you offline maybe. So I'll just drop off. I need to jump on the daily call.
We got our daily call.
okay, it's 1:31. Oh, again we are overrunning. Oh, all right. This I
Can
wanted
we?
to
I think
touch
that is,
briefly.
yeah, I think that is already a very logical end. So let's stop it there. In
Yes,
case anybody else is interested,
I
then
won't
they
take
can reach out to you.
more than 2 minutes.
Oh, okay, 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 okay.
Yes, three strategy I was, I think they are self-explanatory. When you are broking a monolith application, we are already taking mix of these two. um, you should create a new modules as services, or you can split existing modules into, we already talked about mapping the components, or in rare case you need to complete rewrite it. But what we are doing here is we have already shown you, we are breaking it into 35 or 40 microservices. This is this mix of kind of these two strategies we are taking in case of breaking or confirm into microservices. If we talk about team size, what should be the ideal team size of a microservices team? Yes, it should not exceed 8. That's the size of a Scrum team. So it should not exceed normally more than exceed 8. And this is the slide I wanted to show it because I have copied it from one of the IBM presentation. We are facing also the same issue. You can see here 44% of organizations are adopting microservices at the moment, and 39% of organizations are modernizing their legacy apps. 65% of organizations have challenges maintaining legacy apps, and Docker is so popular that 71% of industries are using Docker, and 78% industry is planning to use either Docker or build new microservices architecture. So this is all I wanted to discuss. If I had 10 minutes, I would have discussed a problem statement, so that as a kind of takeaway, so that people can give it a thought. And I'll share this in this PPT so that people can read about this problem statement and come up with a mapping different components, and then we can discuss sometimes 10 or 20 days down the line and see how we have broken this problem statement into microservices and why. So I have also created a repository in my GitHub. This is my GitHub ID. From there you can download. I've created two microservices, one in Node.js and another in .NET Core, using Redis and uh, RabbitMQ as a queue, and both are talking to each other as in an asynchronous way. Feel free to download or clone or you know contribute in that microservice, and then we'll touch base. All right, this is what I had for today. Thank you.
Perfect. Thank you, Ved. I'll upload the recording.
Thanks.
Thank you. Bye bye.
Excellent.
Bye.
Right.
Thank you, Vedvai.